Welcome to yet another Aspire demonstration movie. In this one we'll show renewable whitebox cryptography. In order to fully appreciate this demo, it's better if you first had a look at the code mobility demo as well as at the whitebox cryptography demo. Here we'll focus on the renewability part, which in practice builds on code mobility. So what are the security requirements? Well, if we look at the original whitebox crypto requirements, there the requirement was confidentiality of cryptographic keys. We wanted to hide the keys in large tables and code fragments such that even if a key is embedded in a program, it cannot be extracted from the program or even from the program execution. In the case of renewable whitebox crypto, we actually want to be able to update or refresh keys. So rather than hard coding those large tables in a program, we want to be able to re-randomize them, and then we want those tables and perhaps also some code to be delivered at runtime. So at runtime, the application should download that code and the data from a server rather than finding it in the static code or data segments of the program. If we then also have a script to run on a server that can generate new mobile blocks, so new versions of the tables with re-randomized content, then we can enable a server to send new blocks with new keys or with re-randomized keys to a client application whenever the server chooses to do so. So how does this work in practice? Well, I'm going to demonstrate this by means of the same example program that we also used for whitebox crypto. You might remember this code fragment where we had annotations to mark the input and output arrays of a cryptographic primitive, where we had marked the key of that primitive as well, and then we had marked the invocation of the function call such that this invocation can be replaced by an invocation of a whitebox version. You might remember that the code is then rewritten by our tools, and in the rewritten code you see a call to a function that no longer accepts a key as input, but that instead has the key embedded in the code and tables inside that function. Now to make this renewable, the only thing we have to do is make sure that the content of this function becomes mobile with our code mobility technique. Of course, we cannot annotate this source code because it is generated by a tool during the invocation of our toolchain. But there is an alternative option in the form of the extra annotations file. You can specify an additional list of annotations, and in this case we specify that for a function whitebox generated code client decrypt fixed, that's a function that's actually invoked from within this function here, we specify that it should be protected with code mobility, that the code should become mobile, but that also the data accessed within this function should become mobile. And this suffices to tell our toolchain that the code and data in this crypto primitive should actually be renewable such that it can be updated on a server and then delivered to the client application. So here we're back in our virtual machine with a small license example that we already used to show whitebox crypto. Let me open some files. You'll see here first the overall configuration file, and you see that we specified that an external annotation file should be used. If we look at the source code, you see that the whitebox crypto pragmas are present, and in the extra annotation file you see that for one of the functions, this is the inner function that executes the whitebox crypto, we specified that it should become mobile and that also its data, so those are the big tables that embed the key, should become mobile. Now if we look in our online backend repository, we see that it's empty. And if I look in this directory, there is no build directory. The build still needs to happen. So let me now invoke the build. We're in the final stages now, and you already see that scripts are generated. And these are to renew the keys on the server side. Okay, the build process is done. You see that an application has been generated that got an application ID of B44 and so on. Now, if we look in the online backends, you see that a directory was created specifically for this application ID. And if we look into it, we see that there is a code mobility subdirectory, and in it there is in fact only one block. And if you look at this directory, you see the block, and you see that it's quite big, 150K approximately, and that's of course because it contains the large table of the whitebox crypto. Now, To check the content, we can compute a hash, and we see the value here 8799 and so on. But we also see that in the build directory that has been generated, there's a whole bunch of directories, and there's one here with an R that stands for renewability. And if you look in that directory, what we see is a script that this has the same name in it as the file that contains the code to be protected with Whitebox Crypto. And what we can now do is execute this file, and as argument we specify the online backend directory. If I run this, see that some scripts are invoked, including the one that I mentioned before. So as a reminder, let's look at this hash here. It's 8799 and so on. And you also noticed that the block was generated at 39 past 8. We're done. What has happened is that we generated a completely new file for the Whitebox Crypto, and that file was compiled again. And then from the compiled file, we extracted the data and moved it into the block. We can see that if we look at this directory, there's a new file that was created later. It has the same size, and if we check the sum, you see we have a completely different value now. If I run the script again, so a new version has been generated. You can check here again, this has a later timestamp, and if you look at the sum, checksum again, we again see that it has a different value. Here you saw the old one, C611, now it's 6B, and so on. I'm not going to demonstrate this application in action and consuming these blocks because it's pretty boring and you've already seen it in previous videos. But you can trust us that it works, and I hope we've convinced you that we have to a large extent automated the deployment of renewable Whitebox Crypto, and thus we provide an excellent framework to experiment with this and to do further research on this. That's it.